Okay, so let us have the next form of differential equation, which is the Bernoulli equation. So Bernoulli equation, as I mentioned to you, is somewhat an extended version of linear DE. If we recall the standard form of our linear differential equation of the first order, if we have y as the linear variable, let me write it here. You have the derivative of y with respect to x plus p as a function of x times y is equal to q as a function of x. These are our SLF. And for x as the linear variable, you have derivative of x with respect to y plus p as a function of y times x is equal to q as a function of y. Okay? Comparing it to our Bernoulli equation, these are our Bernoulli equations. If y is the dependent variable, derivative of y with respect to x plus p as a function of x times y is equal to q as a function of x times y to the n. And when x is the dependent variable, there is times q to the n on the right side of the equation. So the main difference between Bernoulli and SLF, factor y to the n on the right side of the equation if y is the dependent variable, or x to the n if x is the dependent variable. Okay? So when this n is 0, if this is 0 and this is 0, so y to the 0 is 1, then it reduces to this SLF. If n is equal to 1, then the equation reduces to a form which is solvable by separation of variables. So to give you the general solution for a Bernoulli equation, let me use the first form, derivative of y with respect to x, plus p as a function of x times y is equal to q as a function of x times y to the n. Okay? So what will be the solution to Bernoulli equation? The solution is after identifying that it is a Bernoulli equation, meaning we have put it in this form. The next is to convert this into SLF. Okay? So how do we convert it to SLF? Since I mentioned a while ago that the difference is the presence of the factor y to the n on the right side. So we want to remove this y to the n on the right side. So what we do is we multiply the given differential equation by y to the negative n. And therefore, what is the resulting equation? So y to the negative n, derivative of y with respect to x, plus p as a function of x times, this is y to the 1 times y to the negative n is y to the negative n plus 1, is equal now to q of x. So we eliminated now the y to the n on the right side of the equation. The next thing is, looking at y to the negative n plus 1 and y to the negative n dy, they are related to each other in a manner that if you let u to be equal to y to the negative n plus 1, that is the factor together with p of x. What is our du? That is negative n plus 1 times y to the negative n plus 1 minus 1. So that is y to the negative n dy. So looking at the first term of the resulting equation, you have here y to the negative n dy. So what is lacking is the numerical coefficient negative n plus 1. So what we need to do also, when we multiply it y to the negative n, we need also to multiply it by negative n plus 1. Okay? So let us try to multiply this by the numerical coefficient negative n plus 1. Again, this is just the numerical coefficient since n is the power or exponent of this y on the right side of the equation. When you add it to 1, then that is also a constant. So multiplying, you now have negative n plus 1 times y to the negative n dy with respect to x plus negative n plus 1 times p of x times y to the negative n plus 1 is equal to negative n plus 1 q of x. But again, this is just a numerical coefficient, which can go with px. If, for example, our p of x is x, and this value is, say, negative 3, then it is just negative 3x, which we can still generalize as p as a function of x. Same thing with the right side, q as a function of x. So let us generalize this to be your p as a function of x. So we now have negative n plus 1, y to the negative n dy with respect to x, plus p of x. If you want, you can put prime to distinguish it from the original p of x. If you do not want, it's okay. I will not use any differentiation with the original p of x. So that is y to the negative n plus 1 is equal to q as a function of x. And again, using this introduction of the new variable u equals y to the negative n, and this is your du, what will be now the resulting equation? So this is negative n plus 1, y to the negative n dy, which is simply our du. So this is now derivative of u with respect to x, plus p as a function of x, and now this is our u. So times u is equal to q of x. And now what is this equation? This is our standard linear form, linear in the variable u. And once it is linear, what is the next step? To find our if, which is equal to e to the integral of p dx. Then the next step is we multiply our if with our slf with our dx. And remember that the result should be, the left side should just be the derivative of the product of the integrating factor and the linear variable, and equal to the right side of the equation times the integrating factor, and then you integrate both sides of the equation, and therefore you have your solution. Okay? So again, you have to multiply the Bernoulli equation by y to the negative n and negative n plus 1. If you have x as the dependent variable, then you have to multiply it with x to the negative n and the coefficient negative n plus 1. Okay? So to illustrate to you the process of solving Bernoulli equation, let me give to you the first example. Example number 1, solve 2x cubed y prime is equal to y times the quantity y squared minus 3x squared. So first is to present it in a form of a Bernoulli equation for us to know that it is really a Bernoulli equation. So you have here your y prime. So if it is a Bernoulli equation, it would be y as the dependent variable, since it is the only the one term only. So we will divide it both sides by, let me change a different. We divide both sides of the equation by 2x cubed. And what is now the resulting equation? So y prime is the derivative of y with respect to x is equal to, that is 1 over 2x cubed times y cubed plus You have there 3x squared over 2x cubed. So that is 3 over 2x, sorry, times y. Three over 2x times y. And now rearranging the terms so that it will be in the form of Bernoulli equation, derivative of y with respect to x minus 3 over 2x times y is equal to 1 over 2x cubed times y cubed. Now it is a Bernoulli equation in which our p of x is negative 3 over 2x and our q of x is 1 over 2x cubed and our n is 3. That is the exponent or power of this y on the right side of the equation. So what we need to do, what are we going to multiply? We multiply it with y to the negative 3. We can also have it at once, yung multiplication of the constant or the coefficient, negative n plus 1. So our n is 3, so negative 3 plus 1 is negative 2. So multiplying, we now have negative 2 y to the negative 3 dy with respect to x, then negative 3 over 2x times negative 2, so that is positive 3 plus 3 over x times y to the negative 3 is y to the negative 2 is equal now to 1 over 2x cubed over negative 2 is negative 1 over x cubed. Okay? And then now we introduce the new variable. We let u to be, again, the factor with the p of x should be introduced to u. So let u equals y to the negative 2, and what is our du? Negative 2 y to the negative 3 dy, which is actually this on the first term. So you have now derivative of u with respect to x plus 3 over x times u is equal to negative 1 over x cubed. And now this is our standard linear form, linear in the variable u. Okay? Then, we find our if. What is our integrating factor? That is e to the integral of 3 over x dx, or that is e to the 3 ln of x, or simply x cubed. So our if times our linear variable or SLF times dx. And it should give us a result that the left side is what? But let us verify if that is correct by multiplying this. So x cubed du plus 3 over x times x cubed is 3x squared. U dx is equal to negative dx. So the left side should be the derivative of the product of the integrating factor x cubed and the linear variable. So checking x cubed du plus u times the derivative of 3x, which is 3x squared dx. So that is correct on the left side of the equation. Is equal now to negative dx. And now we integrate both sides. So x cubed u is equal to negative x plus c. But what is u? U is y to the negative 2. So x cubed y to the negative 2 or y squared is equal to negative x plus c. Or x cubed is equal to y squared times c minus x. And that is now the solution of the Bernoulli equation. Okay? Now let us go to the next example problem. Solve this differential equation. Derivative of y with respect to x is equal to y minus xy cubed e to the negative 2x rewriting it in that Bernoulli form. So rewriting it, so you have derivative of y with respect to x minus y is equal to negative x e to the negative 2x times y cubed. So our p of x is equal to negative 1. Our q of x is equal to negative x e to the negative 2x. And our n is equal to 3. So that is a Bernoulli equation. So what are we going to multiply with this? Negative n plus 1, so that is negative 2, y to the negative 3. So multiplying, you have negative 2, y to the negative 3 dy plus 2, y to the negative 2 is equal to 2x e to the negative 2x. Okay? And now we let u to be equal to y to the negative 2. What is our du? Negative 2 y to the negative 3 dy, which is again this part of the first term. So you now have derivative of u with respect to x plus 2 times u is equal to 2x e to the negative 2x, which is again the standard linear form in the variable u. So finding our if, that is equal to e to the integral of 2 dx, or simply e to the 2x. So multiplying our if with our SLF and with dx, again the left side, so that would be the derivative of e to the 2x times u is equal to the right side, so 2x e to the negative 2x times e to the 2x, that is simply 2x, which we can now integrate. So that is e to the 2x times u is equal to 2x squared over 2, or that is x squared plus c. But our u is y to the negative 2. Therefore, you have e to the 2x is equal to y squared times x squared plus c. And that is now the solution of the Bernoulli equation. You follow the steps of transforming it into a Bernoulli equation. If that is really a Bernoulli equation, then after that, you multiply with the coefficient negative n plus 1 and the y to the negative n. And then you introduce the new variable u, which is simply equal to y to the negative n plus 1. Then it will become SLF, and then you solve or you provide solution with that SLF. Okay? Let me give you the next example. 6y squared dx minus x times 2x cubed plus y dy equals 0. If we are going to check the differential equation, is it linear in y? You have here y dy, so violated is the second requirement, that there should be no product of the dependent variable and its derivative. So it is not linear in y. So it is not a Bernoulli equation in which y is the dependent variable. So let us check with x. So if we want to provide or to show that a Bernoulli equation in the form of derivative of x with respect to y plus p as a function of y times x is equal to q as a function of y times x to the n. That is when x is the dependent variable. So we need to divide this equation by 6y squared and dy. Okay? So dividing it by 6y squared and dy, what is the resulting equation? So that is the derivative of x with respect to y minus, you have 2x to the fourth over 6y squared. So that is minus 1 over 3y squared times x to the fourth minus negative xy over 6y squared. So that is minus 1 over 6y times x is equal to 0. And rearranging the terms, you have derivative of x with respect to y minus 1 over 6y times x is equal to 1 over 3y squared times x to the fourth. So here our p of y is negative 1 over 6y. And then you have your q of y, which is 1 over 3y squared. Our n is equal to 4. Therefore, what are to be multiplied to this? Negative 4 plus 1 is negative 3 times x to the negative 4. So multiplying, you now have negative 3 x to the negative 4 dx. Then that would be plus 1 half y over times x to the negative 3 is equal to negative 1 over y squared. Okay? And therefore, we introduce now u to be equal to x to the negative 3. What is our du? Negative 3 x to the negative 4 dx, which is this part of the first term. So you have the derivative of u with respect to x plus 1 over, sorry, yeah, 1 over, this is not, this is y, yeah. Derivative of u with respect to y plus 1 over 2y times u is equal to negative 1 over y squared. Okay? And then what is now our IF? E to the integral of 1 half y dy is equal to e to the 1 half ln of y, or simply y to the 1 half. That is our integrating factor. Then again, the left side should be the derivative of the product of y to the 1 half and the linear variable is equal to the right side. Our right side is negative 1 over y squared and then times y to the 1 half. So that is the derivative dy. The derivative of y to the 1 half times u is equal to, what is this? Negative y to the negative 3 halves dy. Then we integrate both sides. So you have y to the 1/2 times u is equal to, what is the integral? So y to the negative 3/2 plus 1 is negative 1/2 over negative 1/2, and then times the negative. So that would be 2y to the negative 1/2 plus c. If we simplify by multiplying first by y to the 1/2, then you have y times u is equal to 2 plus cy to the 1/2. But what is u? But u is x to the negative 3. Therefore, you have y is equal to x cubed times the quantity 2 plus cy to the 1/2. And this is now the answer or your solution to the differential equation given, which was found to be a Bernoulli equation in a dependent variable x.